Hello friends, welcome back to our channel Mirror Neuron, which means watch and learn. And today we are going to talk about a very interesting thing that I have seen my colleagues recently asking a lot, which is about hyperparameters, right? Tuning in deep learning models, right? I'll just write the word deep learning. Okay, so what is that one question that I have seen many of my colleagues and also my other friends at other companies has been asking is related to something called as the hyperparameter tuning, right? Now we know, if you have taken any deep learning courses, we know there are so many hyperparameters. Like for example, we have heard about learning rate, which is typically denoted by alpha. Then we are also trying to learn how many layers of deep learning in the deep learning network, how many layers are we going to use. We are also trying to find a systematic way how we can use, how many hidden units do we need, and so on, right? We are also have learned that what is the learning decay, right? Or you can call it learning rate decay is another hyperparameter that we are going to systematically learn from our, and we have so many algorithms for that. Now you must have also seen, okay, I moved the camera a bit. Okay, you must have also probably read many articles or must have already used it in your many of your projects, something like what do you call it, the gradient descent, right? You must have already used the gradient descent, and you must have used it with momentum. These are the techniques which are actually used to make your algorithms run fast, right? You must have heard about RMS prop. You must have learned or used ADAM. So these are the different techniques that you use to speed up your optimizations, right? Which is gradient descent in another term. Okay, commonly known as optimization. Okay, now even these algorithms comes up with lot many hyperparameters like beta 1, beta 2, and so on, right? So there are n number of hyperparameters which we have to use in addition to the parameters that we are learning from the data, right? Hyperparameter is something which you learn outside of your data, right? Which are the cranks of or the knobs that we use to make our algorithms work better. Okay, now in context to all of this, okay, now if you are really thinking where can I learn all of these techniques in a very sequential and very easy manner, I'll put a link in the description section, so you might want to take that course. Many of my friends and even I myself have taken that course lately, and I'll put a link there. These are very important concepts if you are trying to apply for a job in the field of deep learning, and you should be very familiar with these concepts, right? And you should know where exactly to use, why to use, what are the pros and cons of these elements, and your interview questions could be around all of these algorithms, right? Now one of the common thing that I have seen, as I was mentioning at the very start of this video, is a common question that I have seen people ask nowadays is related to something called as batch normalization, right? And you know that in batch normalization we basically try to make the mean and the variance constant within a particular layer, right, in deep learning network. Okay, so you must have seen the formula where 1 over the number of training examples, z of I, this is the mean, right? And you must have seen the variance, which is again 1 over m. And these are very simple statistical formula where we have the zi minus mu whole square, right? And here comes the batch normalization form, and the interview question is more about this particular term. So for example, this is my formula for my batch norm, okay? And your interview question comes right here. So why do we add this epsilon term? Let me use another formula. I'll show you here. Okay, why are we using this epsilon here? This is a common question that is being asked everywhere. Where did this epsilon come from in this formula where we are trying to normalize? Normalization, in other formulas, we know that x minus the mean divided by the standard deviation, right? This is the formula, which is the formula here. If you take the square root of the variance, you get the standard deviation, and this is the formula. But then why do we have this small epsilon here, right? Okay. This is actually a very funny question, but very important to understand why do we have an additional epsilon. And this also shows the interviewer that you have actually understood the concept, that knowing things theoretically and knowing how to implement them on a computer are two different things, right? This epsilon is just to be there to make sure that we are not going to divide anything by 0. What do I mean by that? For example, if this term sigma square is equal to 0, then just imagine this entire term will be not be able to calculate. As a result, what we want to do is we want to not divide by, there could be a probability that the variance of this calculation could be 0, and that will throw our algorithm out of the way, and will not be able to do anything with that algorithm. So that is why we add a very small term with it, so that numerically we are saying that don't divide by 0 even if the variance is 0, but this e is somewhere close to 10 to the power of minus 8, a very small value, which when I add it doesn't make any impact, but technically I'm not dividing by 0, and that safeguards my algorithm. And that is the main reason why we use this small epsilon. Okay, now in summary, I would say learn about all these important topics such as hyperparameter tuning, and Andrew Ng has done a very good job in trying to put them together in a small nutshell, in a small course. I'll put the link in the description section so that you can learn more about it. Okay, all right, I hope this gives you a new idea that how to prepare for a data science interview, and I hope I'm helping you in, even though it is a little bit. All right, take care and stay in touch.